Imagine a place where the laws of physics break down. A place so powerful that not even light can escape. A place where time itself slows to a crawl and the very fabric of space twists and warps. This isn't science fiction, this is the reality of black holes. They're some of the most bizarre, extreme, and fascinating objects in the universe, and yet we still don't fully understand them. What would happen if you fell into one? What are they really? Just cosmic monsters or something even stranger? In this video, we're going to dive deep into the heart of these dark, mysterious giants and explore the mind-bending science that makes black holes the most interesting thing in the cosmos. Buckle up because this journey will take us to places where reality itself starts to break down. Before we can even talk about black holes, we need to start with space and time. Think of space as the stage for everything in the universe. But here's the catch. Space isn't flat, and time doesn't tick the same for everyone. They're both relative. And here's how that works. Massive objects like stars and planets bend space. It's like putting a heavy ball on a trampoline. This bending creates gravity, which is what keeps us and everything else grounded. Black holes, however, aren't just bending space. They're warping it to such extremes that they create a kind of trapdoor in the fabric of the universe. Black holes are born from the death of very massive stars. So imagine a star so massive that, in its final moments, its core collapses in on itself at nearly a quarter of the speed of light. This implosion is so intense that it creates something incredibly dense, warping space so much that it creates a no-go zone, a point of no return. For example, a black hole with 10 times the mass of the sun would only be about 60 kilometers across. Pretty small, right? But the gravity is so strong, it can't be escaped. So if you were to look at a black hole, what would you see? Nothing. The black hole's event horizon acts like an invisible border. Once you cross it, you're gone, and nothing, not even light, can escape. This is why we can't see inside black holes. It's like looking into the void. But we can observe them based on how they affect nearby matter. So even though you can't see black holes directly, we can detect them by watching the stuff around them. Matter can orbit black holes, just like how planets orbit stars. And as these materials get closer, they heat up to insane temperatures, reaching billions of degrees. This process makes the area around the black hole really bright, which is a little ironic considering that the black hole itself is literally black. It's like the universe's most extreme light show. Now, imagine getting close to a black hole. As you approach, things start to get weird. Gravity is so strong near a black hole that it actually bends light. So if you were hovering just outside the event horizon, at a point called the photon sphere, you'd be able to see your own reflection, and not just once. The light from your back would bend around the black hole and come into your eyes, so you'd see yourself in front and behind you. Spooky, right? Time also slows down as you approach a black hole. So from your perspective, everything around you looks like it's speeding up. And if you manage to escape, you'd return to a universe that's aged far beyond what you remember. Your loved ones would be long gone. It's like a one-way ticket to the future. Pretty crazy, right? But not to sugarcoat it, getting close to a black hole can be deadly. As you get closer, you'd experience a phenomenon called spaghettification. This happens because the gravity is stronger at your feet than at your head, and the difference in gravitational pull would stretch you out into a long, thin string. And by the time you're close enough to cross the event horizon, your body would be ripped apart, turned into a stream of plasma. Ouch. Okay, so smaller black holes are pretty deadly, but what about supermassive black holes, like the ones at the centers of galaxies? They're way bigger, meaning that the difference in gravity between your feet and head is much smaller. So technically, if you ventured close to one, you might not experience spaghettification. However, once you cross the event horizon, you'd be in the same boat. You would never return, and space and time would be irreparably broken. The laws of physics would lose all meaning. And at the very center of the black hole, we have the singularity, a point where all the mass of the black hole is crushed into a single, infinitely small spot. At the singularity, space and time collapse into nothingness. There's no memory of what caused the event horizon. Everything is reduced to a single point, So in a way, black holes erase everything that falls inside of them. Interestingly, despite how weird and powerful black holes are, they only really have 3 properties, which is mass, spin, and electric charge. That's it. This makes black holes remarkably simple, and essentially, every black hole in the universe is the same. Sure, their size and rotation speed differ, but all singularities are the same, like fundamental particles in physics. Kinda weird, right? But here's the kicker. Our current understanding of black holes, based on Einstein's theory of general relativity, can't fully explain them. Space and time become infinite at the singularity, and the rules just kind of break down. The singularity might not even exist as we think it does. It's still a huge mystery. Now, there's something you probably didn't know. Most black holes are actually spinning. So when a star collapses, they don't just sit still, they spin at incredible speeds. Sometimes up to 90% the speed of light. And this rotation creates a region around the black hole called the ergosphere, where space itself is dragged along by the black hole's spin. And in this area, you can't stay still, no matter how hard you try. It's like being caught in a cosmic whirlpool that drags everything in. So what happens to black holes as the universe continues to age? Well, based on a theory from physicist Stephen Hawking, black holes might eventually evaporate. This process, called Hawking radiation, occurs because of the quantum fluctuations at the event horizon. Essentially, black holes slowly lose mass over incredibly long periods of time, billions upon billions of years. It's so slow that a black hole with the mass of our sun would take 10 to the 67 years to evaporate just 0.000001% of its mass. And for the supermassive black holes, their lifetimes are practically unimaginable. They could last for 10 to the 100 years. So will we ever truly understand black holes? The truth is we probably never will. Not completely. We can't see inside them, and the theories we have might not even be right. But that's the beauty of science. We're still exploring, still learning, and there's so much more to discover. And who knows? Maybe the secrets of black holes will be the key to unlocking even greater mysteries of the universe. Thanks for sticking with me through this cosmic journey. Black holes may be one of the most confounding and terrifying phenomena in space, but they're also part of the wonder that keeps us looking up at the stars, wondering what's out there. Don't forget to like, subscribe, and hit that notification bell for more mind-blowing space content. Until next time, stay curious, and we'll see you on the next one.